Yeah.
Good morning. You're not sick, are you?
No, I'm okay, I think.
There's definitely something going around.
Yeah.
I'm sorry. Could you say? I can? Yeah, I will.
Mr. Townsend,
Yeah.
is there a reason I'm in your class advisory all week?
Because you haven't been turning your homework in.
Hmm?
You got missing assignments. You need to check grade bureau. Are you missing your phone? They have it down in the library. You can go get it real fast.
No!
I don't have anyone else to vote for. I forgot to get my name on.
Bro, I didn't know you could take your top and Ella. I swear, like, I have really good eye.
You're gonna be good for four.
No, I don't want it. I don't like attention. It makes me like,
The dancing would be.
yeah, see, I'm gonna like grade my like before, so I can't do it. No,
Well, we just went through this and I was like, I don't know if they have 10 votes.
huh?
10 votes.
Who's voting for me? How do you know that?
It's open.
Wait, you can see who voted? Wait,
No, it's just a gigantic list of girls and you have 10 votes. I don't have anyone else to vote.
oh, you mean in general?
Yeah.
I don't have to vote.
No.
Don't do that.
Wait,
I really don't
No.
like it. Like,
what are we voting for?
Homecoming court. A bunch of people,
Yeah,
I forgot to get my name off the
makes
thing.
me
Because now
like-
people can vote for you and I do not
go
vote.
and then teachers pick too.
Oh,
Wait,
really?
Mr. Townsend, don't teachers pick for homecoming court?
Nobody asked me, but
Oh.
that doesn't mean they don't.
I think they do. Wait, you said turn 22 in, but on here it says turn 20.
On what?
22. That's oh. On that it says 22.
That's right.
But on Google Classroom it says 20.
Yes, but you have to wait for me to make the assignment. All right, y'all did have a handout this morning, so please pick that up and number it as 24. We are going to be practicing some of the stuff we learned last week. So the handout that you guys picked up is practice over power rule, so that should be a pretty easy one. But we have not done any circuits this year. Again, we do quite a bit of Khan Academy at the beginning of the year. Khan Academy is great for just drill practice, practicing getting the answer right as many times as you need to. But especially next semester, and a little bit this semester, we do these circuits. So it's a little bit different way than just giving you a worksheet with 18 problems or 15 problems or whatever. So I will explain how to do that, but you should number it as 24. And because this is a power rule one, the topic's just a little bit easier, so I don't think that one's going to take you too long. I picked out 2 Khan Academy assignments to move on to after that. One of them is practicing the quotient rule, and one is practicing the product rule. So you guys have practiced that a bunch already, but probably not enough to where you need to be by our next test. And then finally, the number 22, which was your homework, that needs to be in Google Classroom, but you can do that at the end of class. And yeah, I don't even have it in Google Classroom yet, so I'll put that in just a second. But let me give you the directions to our circuit here so you know what the directions are. And again, we do a bunch of these, and essentially it's a worksheet with just a bunch of questions, but I don't know. It's got the answers, so it gives you kind of a hint if you're on the right track. But you always start here in the top left. This is box number 1. They've already numbered it as question number 1. And then you're supposed to work out the answer. So if we're applying the power rule, y prime would become, what's the first part? Okay, and then somebody else, the second term becomes, okay, somebody else, the third term, 9, and the derivative of the constant is 0, so we don't have to write that. All right, so there's the answer to box 1. So notice in each box it's got answers, so we need to find the box that says 15x squared minus 8x plus 9, or something equivalent to it, and that is supposed to be box 2. Down here. So that was the answer we got for box 1. Okay, so that makes this card 2, question number 2. Again, the questions are not in order. They kind of jump around. But notice if we had gotten an answer and it didn't match up with any box, then we would know something was wrong, and we would know to check our answer. But do one more. But you do this one on your paper first. Write out what you think the derivative is, and then see if you know what to do with that. But I will say it one more time. Okay, what did y'all get for derivative here? 3x cubed. Bring the power down, lower the power by 1. Okay, I agree. Everybody okay with that derivative? Again, this is just power rule. There shouldn't be any product rule, no quotient rule. It should be, now some of them you have to rewrite like we did on the number 20 book assignment, but when you get this as your answer, this is supposed to tell you where question number 3 is. So you have to find the card that says the answer is 3x cubed plus x. Okay, so that would be the top right of the back page. So you need to label it as question 3, and then you should do that one next. Generally speaking, these questions kind of bump up in difficulty. Again, I don't think this one's going to be too bad because it's just the power rule. Also, one reason I really like to do these circuits is the person who makes them is basically works for College Board, and she does a really good job of asking the same things, but sometimes with slightly different twists. So I don't think this one has much variety, but typically in a circuit, like you'll do a couple that'll be real basic, and then you'll get one that's got a table instead of a function, and then maybe a piecewise function instead, and then maybe they give you one where they give you the graph, and then they give you one where they throw in a trig function. So it does a good job of giving you like a wide variety of question types. So, and then the last thing I need to tell you about this, and I'll let you keep going here, but when you do the last question, this one has 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 24 questions. So when you work out, you figure out what box number is 24, you need to work it as well, get your answer, but your answer to the last box is supposed to loop back to this. The last answer should go back to the first box's answer. So it kind of, everything just kind of fits into a piece, like everything's got its own slot, and if that last one works out for you, then you can feel pretty confident about the rest of them. But you work a question, your answer's not there, that's a hint you need to retry it. If your last answer doesn't match up with the first answer from box 1, then something was wrong. I don't know, that's all I can think of, but there might be a few things that show up. Maybe some notation or something that you haven't seen yet, so you're obviously welcome to ask about those when you get there. So let me give you a few minutes to actually get some of this done, and then I'll come around and help finish it up. But if you work quickly and you just blaze through this, you can move on to the 2 Khan Academies when you get there. You don't have to wait for my permission.
For number 8, how would you do product rule with 3?
You couldn't do product rule. You don't
So
need
I would
product
have
rule.
to.
You can still just do power rule. You can bring the
Yeah.
power down,
Oh, and then multiply
lower the
it
power by
out.
1.
And then multiply it. Okay.
I don't know that you need to multiply it. Check to see if there's an answer that looks like that first.
Okay.
So, I'm gonna cheat a little bit.
You need to work there anyway, so.
Yeah.
And it may not be 7. I mean, I'm not saying it's not. I don't know. I don't know the answer.
But how would I
Well, you could do the product rule, but this isn't supposed to be the product rule. But you can multiply this. This is x in the first times x in the 1/2. You multiply things with the same base, it's like adding the exponents. For the power rule. Let's just use an exponent if you have a statement.
Yeah.
Yeah.
Oh, so it doesn't.
I wasn't saying it wasn't, I'm just saying, I wouldn't make that assumption. Again, this one's a little more basic, but a lot of these we look at, like, 3 questions will be like the same question, but like, one thing would be different. So, it's easy to, I don't know.
Hey, you look good today. Probably out.
So I'm pretty sure. I think I'm going to answer this one. Which means I probably
I just multiplied that together.
It might be dividing things. X to the first divided by x to the 1/2. How would you divide things at the same basis? That's subtracting. It might be given that. Dividing things with the same base is like subtracting the exponents. So x to the first divided by x to the 1/2 is the same as x to the 1/2, or square root of this. I'm just saying that it may have rewritten it that way, I don't know. The other thing you guys can do is if you do get stuck on a question, you can skip it. Just work a random question, not knowing what question number it is. But then at the end, if you only have a couple, it's a little bit easier to see what number it was supposed to be.
I don't think I understand what you mean, because this is x in the third.
What is x to the third divided by x squared?
Well, it's x.
Because when you divide things with the same base, you subtract the exponents.
Yeah, but how would that apply to this?
Isn't it x over square root of x part of it?
No, it's x over square root of k.
Oh, my bad. Okay. I thought it was square root of x. I think it'd be something else.
Because the answer would probably not be this. Hold on, sorry. Wait, so do I get to write the circle one? This? Yeah. Bring the power down. 3.
Oh, because that's not.
Yeah.
But not this one. K is just supposed to be some generic number, right? What's the derivative of 3x? Okay, and what's the derivative of square root of kx? They're both 3 and square root of k are both just numbers. So just like this derivative of 3x is 3, the derivative of square root of x, square root of kx is the square root of k. It's just a number. Any stuck on yet? Again, don't stay stuck on one for too long. Just pick a random question and come back to it. You'll have some context clues if you narrow it down to just a couple. But also when I come around, if you need help getting unstuck, then please let me know. Okay, such as? Just do the power rule. Bring the power down. So 3 up front. Lower the power by 1. So now it's x minus 5 squared. No, not x squared. Okay, you brought the power down. Now lower the power by 1. So x minus 5 squared. This is supposed to be just for 3. I don't know what that is. Yeah, I would stop there and see if there's an answer that would that. If there's not, they may boil this together and multiply in 3. I don't know if they would, but also not required, but a good idea to mark the questions that you missed the first time. If you circle those or something, you will remember which ones you missed if you ever look back at this. Which is always a good idea before a test.
these, what do you want to see, or doesn't really matter? Would you rather have us do fold it out?
Well,
And
on
then
this
do
one,
the power rule, or then do the power rule, or just start off by folding this part and then do the product rule?
I don't have a preference. Whatever you think's easier, but technically you shouldn't have to do product rule on
Yeah.
this one. You could just do power rule.
Yeah.
So. Again, if some question just seems a lot easier doing product rule or quotient rule, I guess you could do that. But all of these are supposed to be able to be done with just a power rule.
Oh, just how would this be done with just a power rule?
You could FOIL that numerator together.
Like that?
Yeah. Okay. And then you could split apart your fraction. Put x squared over x, and then minus 25 over x. And then you can just do power rule twice.
Okay.
There's nothing wrong with product rule and quotient rule. It's just that this worksheet is supposed to be practiced in power rule. Just trying to see if there's any common issues.
What's up, Luna? How are you? Better. Sorry, a long time. For that, yeah. I think it's great that I follow somewhere.
I think it's longer than first. I'll be right
2
back.
weeks in a row, all week.
Yeah, K is just some generic number. No, you shouldn't need 4 terms there. Just treat K like a number. Like if this was a 5, you're gonna change this to x to the 1/2. You would bring the power down, so that's gonna make it K over 2. Lower the power by 1, and then
I
rewrite.
just figured out 12.
Oh, you did?
But you split it like a fraction. And then power rule, so bring that up to the -1. And then add those, so it's x to the 1, so and then bring that up to -1. And then all the derivative, yeah.
Okay.
I'm not sure what my comment is to that, but let me give you, again, really, we should just be trying to do power rule only. It's not that quotient rule can't work, but with all those negative exponents, that one looks really tough. So.
Can you just multiply that into 1?
Was it this one? Yeah, so I think what they're intending you to do is to just split apart your fraction first. So you could put this over x to the -3 plus, and then put this over x to the -3. Because when you divide things with the same base, these both have a base of x, you subtract the exponents, so that becomes x to the negative fifth. Divide things with the same base, you subtract the exponents. And now if you do the calculus, just do the power rule twice, it's going to be a lot easier. So even in times like you are going to be on the hook to be able to do quotient rule, but it's still nice to have options, because on the test, if you did quotient rule and your answer's not there and you just can't figure it out, maybe you could at least rewrite it like this. And, okay, the first part looked good. You brought the power down, lowered the power by 1, simplified it. Okay. Oh wait, that's a times. So you can't just take the derivative of this and then the derivative of this and multiply. We could either do product rule, or let's just multiply. Because when you multiply things with the same base, what do you do with the exponents? Okay, so that's the same thing as x. So the
Right? But I found what it goes to.
3 6 plus 4 6 would be 7 6. Yeah. Okay, but that's not calculus yet. That's just exponent rules. But then that's going to be easy to do the power rule on.
Right here, 13 and 14. Okay, hold on.
This one's off. So you're treating k like a variable here. This k is just a number. So if this had said, if this had said 5x, what would its derivative be? Okay. That one, I'm going to put them in differently. This is just a number, just like 5 is. So what is this derivative?
Times 2/3, and you get 7 6. And then you first add those, so you get negative 5 6. Unless I'm doing it wrong. But this one has 7 6. But I
Same way that this, you bring the power down, lower the power by 1, and it goes away. This, you bring the power down, lower the power by 1, and that goes away. You just get the number.
1/2 is
Square root of k is just a number.
1/3 is.
So this should be your second term after.
5 6.
And then 5 6. Okay, so you get 7 6 and you multiply them. Is that what you said?
Yeah.
Is 7 6 x to 5 6. But I'm not gonna see if that gets missing.
Well, one thing is, negative 5 times negative 5 But also, I don't know if they intend for you to do that. You can just do power rule from the beginning. You can bring the power down, lower the power by 1, so that gives you 3 x minus 5 squared. And that might be LED. I don't know. So the power rule on that whole big thing.
Oh, this just did this, added this from the beginning.
Wait, what? Oh, we have to do all the extra?
No, that makes so much more sense. So, so then it would be y equals x to the 7 6, and then the power raised.
Somebody ever had their hand up? That was yours? Okay, I'm sorry.
Being 7
Wait,
x
what?
to the
Number 22. What assignment that we worked on in 2 classes?
No.
Turned in.
So these two get added from the beginning.
And it's 7 over 6?
Not
Yeah,
yet.
it's x to the
Anytime I have to
7.
go turn something in, I will verbalize it at the start of class and it'll get it's hard.
Yeah. But they get 1 6. Got it.
Yes.
That's so much easier.
Clearly not paying attention.
I'm just making sure.
There's just too many ways to solve these. I'm really
No,
bad.
I I'll say it several times, but in the meantime, just keep it in your binder.
So. So, and what you do
So notice, even though you guys have a good idea of what the power rule is and how to use it, there's still some question types that can come up that you can feel a little rusty on, so. Kind of debated about whether we should do this worksheet or not, but it looks like it was probably worth.
Wait, I'm getting this.
Can you multiply,
Why are they getting that?
you said they had to get rid of.
Multiply things for the same base you add. So like x times x or x squared, you're adding x.
How are you gonna keep, why do you still have to keep? Wait, where?
But yeah, I'm getting everything. So then you would do
You have to
k
explain.
over 2 squared x something. Because it's gonna be this one. Yeah. Plus
See, wait, let me see yours.
I got the first one.
Oh, you add those.
Wait, but what is, how is it getting, why do you keep this base?
Why would I
And
do
then
that?
because if you take the derivative of it. Oh, do you keep this always one? So you keep the derivative, it would be one?
Wait, what?
I don't know, I think I'm confused.
So I just did, I took,
So
I
you
changed
just
that
keep it,
to
you're keeping it together?
Yeah. How did you
I
separate
don't know why. Just don't ask me.
Wait, but I don't know how to go the x one away.
See, because you take the derivative of x and it's one. But wouldn't you also take the derivative of k and it's one?
Skip that stuff.
Yeah.
Yeah.
I don't know.
Well,
You have your calculators?
yeah.
Yeah, well, it's coming in today. I'm scared it's gonna look like boxing, but I'll show you. The back is so cool. Have you know Anna?
Yes.
Copy her basic.
Wait, and shoe clips?
Yeah. I love her. I didn't love those last year, but she loved those. And they didn't have it. Really? So I'm like copying it. I'm scared it's gonna look boxy though. But I love the back. And I think it's like a little bit.
Mine is pink with ruffles.
Yeah,
It
Casey's
sounds,
awesome.
it sounds personal.
So you just treat it as any other like you can't actually have one half.
Oh, it's so cute. I love it. Okay, I don't know.
Okay.
The exit you always see the
So-
girl. But you can't actually do one half times.
So this space.
So you just,
I don't know.
Did it connect at the end?
No, I'm not
They're
done
multiplied
yet.
by 2.
I'm
So,
wondering.
okay, so 1/2 of n is equal to x. So that'll be, I don't know, we didn't figure it out.
Well, first of all, I messed up and had to go back and forth with a bunch of different problems till I realized, wait a minute, that answer on that should just
Yeah, sometimes I don't number them until the end, just
Oh, so then it's.
that way I don't have to redo it, but.
Yeah, okay, we're at the.
So now it's. which is going to be k over But why doesn't the k go away? Why does the x go away but the k doesn't?
I'm a little bit confused.
I have another question.
Okay.
So for this one, why does the k not go away but the x does?
Well, k is just a generic number.
And x is x.
So like,
Wait.
x is a variable.
Uh-huh.
K is just like a number like 3 or something.
Okay. So
right here, and you treated it right on the left, correctly on the left. You said it's a number, so it's going to make the derivative that much bigger. Brought the power down, lowered the power by 1. I'm good with that.
okay.
And then over here, like, let's say that instead of calling the square root of k, let's just say it's 3. Because this is just a number. What's the derivative of 3x?
The derivative of 3x is 3.
Okay, so the derivative of
Oh, so
square
if you
root-
reordered that to the x being after it, it would be.
Yeah, it's the same thing. It's just that in math, sometimes we put it in front, because if you put it behind, it's hard to know if it's under the square root or not. So that part's just square root of k.
Okay. So this is the same thing as saying.
Mr. Townsend.
Yep.
How would I do this one with when it's like two variables like this?
Well, k is actually just a generic constant. Like it's a number like 3 or 5 or something.
I never would.
So it's like, so would I like,
So this is going to make your derivative k times bigger.
oh, so is it like you don't treat it like this? So, so you wouldn't actually pull it out, it would just be square root? Because it's like, it could be any number, right? And x is just 1.
Yeah, the derivative of this would be square root of k.
Okay.
This one, you can still do the derivative of square root of x, and then multiply your answer by k.
Okay. So it would be this, it would be just this, right? With the on top. Okay, alright.
Okay, I've gotten one question a couple of times here, so let me talk about it on the board, and you can make sure that it's not one that's giving you issues before you tune me out.
Alright, I don't know if
Where did it go? 16?
15.
It's going to be this one. I don't know the number. As somebody that has finished, can you tell us what question number this ended up being at the end?
14.
Number 14? Okay. So, I think what's throwing you off on this one, or some people, is that k is just supposed to be some generic constant. Obviously, it's a lot easier if they just make it a number like 2, 3, 5 or something, but it can be a generic k as well. So, if this was like 2 or 5 square root of x, to take its derivative, you would just say, well, it's going to be 5 times, or in this case, k times, what the derivative of square root of x would be. So you would bring the power down, lower the power by 1, move it down there and simplify. And then over here, again, k is just some generic number. So just like the derivative of 5x is 5, the derivative of negative 2x is negative 2, the derivative of square root of kx is going to be square root of k. It's just a constant times x. And I believe that matches up with I think it matches up with one on the back. Yeah. So that must mean that this one is 15 then. There's where it's written like that.
Mm-hmm.
So I can't say that we do that to you guys a lot on our test, but we do sometimes throw K at you as some generic constant. Just like any other number, it's just a little harder for our brains to register because we prefer it to just be a number. But okay, did anyone have any follow-up to that one, number 14? Okay.
Should we do number 15?
I will. Yes.
How do you do 15? I thought you said prior through.
Okay, I'm about to do it on the board. You can just follow. Okay, I had a request for 15, 2 different people here, so. So just keep in mind, we have already learned quotient rule, so if you'd rather do quotient rule, in theory you can, but I promise you, if you can use power rule, that's almost always the smarter way to go. And what I think they want you to do on this one is split apart your fraction. So you can put this over 3x squared as long as you're willing to put this over 3x squared as long as you're willing to put this over 3x squared. You can split apart numerators like that, not denominators. Fractions don't work that way, but numerators you can. Then, even more simplifying, this is 1 because anything divided by itself is 1. These could cancel and reduce a little bit. And actually, I'm going to move it up. And then this could move up as well. So, splitting apart my fraction to give me 3 terms. Simplifying each fraction with exponent rules as much as I can. And then, finally, you do calculus. The derivative of a constant is 0. The derivative of this guy would be power rule. So bring the power down, lower the power by 1. I'm just going to move that straight to the denominator. And over here, bring the power down, lower the power by 1, and then move it to the denominator to make it a positive exponent. Of course, adding 0 doesn't do anything, so I don't expect to see that as part of one of the answer choices. But is this how one of the cards looks, or do we need to simplify more?
One of them looks like that.
It does look like that, okay. So my guess would be is this very first step. Splitting apart these fractions. So if that was the key that you didn't think of, please mark this question in some way to remind yourself to look back at that. That's too important of a skill to not be using. Okay, I'll come back around. So call me over if you've got something specific to look at. Something else to keep in mind, our test is still not for a couple weeks, but on the AP exam, this would be like a no calculator question, so they give you 2 minutes to do it on average. So you could spend more time on it, but then you may have less time on other questions. On our test, we tend to give you more time than that. We try to give you less and less time the closer we get to the AP exam. But on your test, you could work it like this, and then if you still had an extra 20 minutes, there's nothing stopping you from also doing the quotient rule and making sure that you get the same answer both ways. So sometimes you can catch some mistakes if you're willing to put in that extra work.
So Diego showed me, where is it? Right here. He did the derivative of the top to get 3x squared and it canceled the 3's to get x squared minus 6. And what I did though is I looked at it as like 1 to the x over 3 and I did like 1/3 x cubed and I took the derivative of that. Is that wrong?
No, you're both doing the same thing. Because when he brought the power down and made it a 1, right? Because 3 over 3 became 1. And you just said that there was already a 1 there, 1/3. And then you did the derivative and then he did the derivative. You should still end up in the same place. They're both exactly the same thing.
Yeah, but he got x squared and I got 3x squared.
Oh, yeah. Okay, so I was with you right here. You didn't do the derivative yet, right? You just rewrote it.
Yeah.
So when you bring the power down, what's 1/3 times 3?
3 or 1. Oh,
That's why it should be 1. Sorry, I didn't look at the next step.
that's not bad.
I just don't see that.
Mr. Johnson,
Yes, sir.
can you help me real quick?
I can.
Cool. Our whole table.
Huh? Your whole table?
Yeah. I split it apart, so C over X plus X. And then, so, yeah, so this would be X squared over X, which is X. So, yeah, think about that, right? And this is 1 over X, so it's X to the negative 1, right? So it's 1 over 2 over X.
Well, it should be negative. When you bring the power down, it will be negative.
So, 1 over negative root or negative 1 over.
I don't know why there's a split root in there, but you bring the power down, it becomes negative. You lower the power by 1, X is negative 2.
Oh, so it's 1 over X squared.
What?
Negative 1 over X squared plus, and then the thing over that is just.
I didn't know which one was it.
Top left of the
Yeah, I got negative 1 over x squared plus 1.
Yeah, that's what we're
But I
doing.
can't remember.
Yeah. Oh, wait. Did you do 18?
I don't know if it's like the other way.
I think
Oh, and then,
total math says we're right. Did you do it?
so yeah, you still need to add your fractions. Get a common denominator and add
Oh,
your
we
fractions.
got negative
Or
1
it'll
over
make the
x.
same.
Oh, I can do that. Wait, what? Oh,
Bring the power down, lower the power down, you get.
Because
you took like.
the power move for X and 2 of them, so 1 square
but wouldn't the derivative of yeah.
Yeah, this, like, you said something, but I'm just gonna go ahead and
There's one,
Thank you.
nothing looks like it.
It's like wrong though, like, that's not supposed to be the answer.
Yeah, it's 23.
What? Wait. What?
Because the answer for that one is answer to that one. And that one's 24.
Stop. No.
I worked backwards for a second.
So I got the right answer, but the problem
Wait,
is that
so
I can't
I'm just gonna go with it.
find square x into this.
Yeah, but where do we go from 18?
No, I'm gonna try doing it like this. Try this one as 19 and just see where it takes me. Because I guess if one is messed up, they're like all messed up.
Well, maybe we're doing it wrong.
I'm pretty sure we're right, but there's no, there's no.
Which answer is this that?
That's.
2
Wait,
minutes.
let me ask.
Oh,
I'm not thinking that. No, we're not. No.
This,
He definitely
this is
messed up.
here. Or no, this is.
Process of elimination. Can't be.
Oh, okay.
Can't be
I
that.
didn't know.
It most certainly is not that.
Yeah, so if you need a big fraction, there was this button.
But it's okay.
If you use that button, it lets
So
you
if
like type
anything,
in
it's
something
this one.
further and then like you type something.
But that's definitely not it.
This one okay?
It has to be this one or this one. Ooh, girl.
Okay, looks like you use quotient rule and the, okay, but if you do quotient rule, you're also gonna have to do product rule, because yours is the top. What's gonna be a lot easier here, if you use FOIL this numerator, you're gonna get x squared minus 25, and then split apart your fraction.
I don't want
Square
that.
over x and put minus 25 over x.
Wait, what'd you do?
And then
I'm
you
gonna
do
try
power of
quotient
y.
rule, see if it works.
Okay. So, I'm not saying
You
your
know how that
process
goes.
is wrong, but it's a lot easier to make it fairly specific. Yeah, so I think this one.
Wait, is it on the bottom? Is it the numerator or denominator?
It's this one. Because they added these two together, so instead of calling this one, it's called x squared over x squared. Yeah, they got the common denominator.
Oh, right, x squared minus 1 over x squared. Oh my god. It's right here. Found it.
That's for
How?
about 10
Wait,
minutes.
explain. Oh wait, no, just kidding.
Quotient rule. That took too much. I know. You got me messed up.
Come on now. Wait, how did you take that over x squared? Okay, that makes sense.
Remember, I also want you to practice product rule and quotient rule on Khan Academy, but that's only once your worksheet's finished. So I don't intend for that to be homework, but it kind of just depends on how much longer y'all need to get there.
Look at you go.
What did you have down for 12?
12?
I never laid them.
12 or
Okay.
Where is it? I think I lose my plot.
bottom right.
I finished it.
Oh. There you go.
Oh, I have it.
Thank you.
derivative of the numerator,
So what did you do here?
denominator left alone, minus the numerator left alone times the derivative of the denominator. All of the denominator squared.
Okay, that was good. Now to go. Based on what this is asking for, if you can type it in that way, it should know that it's a quick one, it should be okay. But you've got a small fraction within a big fraction, so that might be hard to type in. But if you click in the box, I think it gives you that fraction. So yes, this should be fine too. Because it doesn't say like you need to simplify to a certain point. So if you click in that box, you do that one, I think. Yeah, you can write it as a fraction. So that gives you your numerator and denominator percent, how to do that.
So like y equals k plus 1? Or just k? I think it's just k. Sorry about that. Because b is a number. Because b is a number, just like how k is a number.
Wait.
So like,
Start over. Why is it B is a number?
b is a number, so like say b equals 1, then that would equal 0. So because it's not x, it's going to act the same as a number.
Okay, right here. Why are we saying
That's how we explain the other one to me. So k, is k an option?
Yes. Wait, I don't
two
know.
minus negative 3?
So remember on the other one how k of x or kx, or it was like
You're
the
doing
square root
negative,
of
you're
x.
subtracting, or you're adding the negative instead of subtracting.
It's this.
No, it was the other one. It had a k in it.
Oh.
This one.
The first one.
How it was like this
Then
and
you're
then
going
for
to
the
class
x
for
on
it,
this
and
side.
then move on.
And then it would just be the same as like negative 2x plus the derivative of that was the derivative of the square root of k times x is the square root of k. Because of this rule.
I need that.
Yeah.
I don't understand.
I can't do that.
Okay. I'll just go to the next because I don't know. But like what?
Yeah.
Okay, so before I would do any calculus, I would say, is it multiply things on the same base?
And that's what I'm saying.
It does work.
4, 6,
What is
36.
No, like,
7 or 6.
he didn't want all of them.
Oh, they
That's
dimension?
a whole lot easier to do the derivative. Bring the power down, and over the power by 1.
I don't understand.
K is just a generic number,
Okay.
and I guess B is a generic number too.
But how do you know that?
Like,
Why?
I don't know, it's a standard math, but K and K is just a number.
So
It may say in the directional button, but we're not like trying to mix variables up here.
So-
So if this was y equals 3x plus 7, what would the slope of that be?
Oh, got it. Oh, okay. I get it. That makes so much more sense.
So
Wait, where was that? 21. Oh my goodness.
the last one.
I'll just take time. So
Yes, sir.
would B be like the same thing as K, just so like a,
It's just a generic number.
would this just be 1 then? Like, oh, this is K plus B, right?
I'm good with this derivative. If this is a constant, though, what's the derivative of the
Zero.
constant?
0.
So that should be 0.
So just 1.
1. K.
Oh, actually.
Wait. Come here.
Yeah.
Like, just pretend like there's numbers here. If this was y equals 5x plus 3, what would the slope of that be?
Just be 5, right?
Right, whatever this is, right?
Mm-hmm.
So derivative means slope. So your derivative should just be k in the end.
Okay, alright.
Hopefully in advisory they talked about there was a slight change to the bell schedule. It doesn't really mess with us much.
Yeah, A-lunch is 5 minutes shorter.
Well, I think A-lunch was 5 minutes longer than the others for some reason. So now advisory is 5 minutes longer. Our class time still starts the same time. So just pointing that out.
Oh, it looks like just
So if you didn't know that and lunch felt a little rushed today, that's why. Because you're now down to 5 minutes to get to lunch and 30 minutes for lunch.
So is that what you brought?
I wish Khan Academy would make a sound if you got it wrong. That would be.
I think it does.
Oh, does it?
We just viewed it before that
I
happened.
know, why your mom is so evil.
Well, there's always a few people that forget to mute, so it would just be interesting to see how many are getting the first one wrong.
What conjugate with all the time?
Oh my god, it's like me.
I think the first beep should be like, your first mistake should be a beep for 1 second, and then your second mistake is 4 seconds. Or 2 seconds, and then your third one 4.
So this gets exponentially longer.
Yes.
Are you trying to embarrass us?
No.
Yes, you
Y'all
are.
need to slow down sometimes.
Where do we turn in 22?
Into my hands or Google Classroom.
Into his hands. Oh yeah.
You have to refresh. I added it since y'all been in here. I don't think I have your number 20 either.
I turned it in. Was that due when I was not here on Friday?
Yes.
Okay. Yeah, I turned it in though. Sorry, Luna, I was not here.
I thought it was a planned absence. I thought you were doing like a school visit or something.
No, I was just like sick.
You weren't driving to Tennessee to see your boyfriend?
Oh my god. Actually, I did on Saturday. But it was like just a slight sickness. It was just like sinuses or something, and I didn't want to wake up and go to school, so. Just an excuse to stay home. Yeah.
It's not the AP attitude.
Facts, it's really not, but somehow I get by.
Somehow.
Somehow I
Good to
get
get it out of your
You know how much
system.
school I missed last year?
We
And I
never had
still.
an AP attitude in world. and we
No, I
both
never
got
had an AP
C's.
attitude anyway, except chemistry. I had an AP attitude, I was good. Actually, I was alright. I wouldn't give myself the word good. But I
You
did
were convinced of those
good.
notes.
I did good on my exam and in class, so it's really all that matters.
You know, that's how a lot of people fail out of college, is they think they don't need to go very often. And then
Well, I'm not gonna fail out of college. I know I won't. Because if I like start stressing out, then I'll go. That's what makes me go.
Okay. So what's it want? Derivative at that point, or you want the whole tangent line?
Okay, what's the derivative of tangent? Okay, and what is the derivative? Well, we can plug those points in. If you're making an equation of a tangent line, always start off at point slope. They're gonna give you this, which I think was pi over 4.
Are you in North America?
Yeah.
Sometimes you have to define this
By plugging this into the function, but I think they need this to be 1. So then you just have to find the slope, which is going to be the derivative at that x value.
Yeah, but I don't think there's one here.
Secant's the reciprocal of cosine. Cosine of pi over 4 is square root of 2 over 2. So the reciprocal would be this. Or you square it, it becomes 4 over.
I got it. Mr. Townsend's not gonna vote for me on homecoming court because he knows I spot him.
As a punishment, he's gonna go.
Do a circle. You have to know where this is, have the point memorized, and you have to know secant's reciprocal of cosine. So if this is cosine, you flip it over to get secant, and then I just square it.
I'm gonna
So
vote for you.
all that to
because
figure
you
out at
voted
that
for me.
instant, the slope is 0. So you have to use the derivative of that.
Now you're stressed out. See, now you feel my pain. Now you know how scared I am.
Mr. Townsend,
I'm not.
you should get like little whiteboards for us to do our Khan Academy scratchboard for.
I have whiteboards you could use.
You do?
Where?
The problem is, like, as you make mistakes and you learn from your mistakes, I'd like you to have it written down somewhere you could look over.
Can I please use a little whiteboard?
Can I use whiteboard too?
Don't look at how messy it is.
I would never guess.
Oh, good.
You have Legos in there.
Nope, I should.
The question is methods.
Alright, my food is. I'd still rather do that.
That's a big old Lego collection.
Most of those are from another too.
Really?
Yes. Ooh, it has like a graphing thing on there. Fancy. 4 has this right here.
You guys have just under 20 minutes. If there's something I can help with, you need to let me know.
Is 22 due starting next class, or is that due like that?
It's due now. It's about homework.
Okay, well, it says homework turn in.
How long is it send it in? You should have it done.
Yeah. I'll see it on the devices.
That'll be late for me. I'll do it tonight. I really forgot about it.
I'm usually guaranteed like half off on my homework anyways, so.
You just not finish it?
Never, no. And then he signs me up the entire week, and then I finish it in like 2 days or 1 day.
Well, the goal is that you learn to do it on your own, so I don't have to call you in here.
Yeah, your inbox is always full. I've tried to sign up for classes to do homework, but it's almost always
No, I
full.
have it closed now.
Oh, okay.
I did have it open, but I was seeing a bunch of people that I didn't know, and then they went in math help, but, which is fine,
That's like-
nobody else needs math help, but I need to be able to help my students first.
I see.
So then I started closing it. So if you just need somewhere to go or you need some help, you just tell me when I can.
From what it looks like. So,
Mr. Johnson, would I need to simplify it more than this?
Depends. I think Khan Academy can figure out if it's equivalent, so I think it'll be fine.
Oh, cool.
But as a multiple choice question, I'd almost guarantee they'd at least factor out the GCF.
Okay.
And then they might get a common denominator. But it has some way to try to tell if it's on blank. You don't put it in carefully. I didn't tell you the only way to erase these are with your shirts.
That's fine.
You don't care?
No.
Okay.
I hear you.
Just use your palm.
Yes. I'm not really worried about it.
There's some,
Uh,
and this
I hate
usually
those
helps.
papers. They never circle them.
Yep. Ew, wait. I didn't want to rehear that. It's like hearing it all over again. People
Like,
like
stop.
It was bad. I mean, I have to say, like, that's a nice thing to do. Like, that's a nice. Yeah. That was. I literally was like, I.
You didn't even know what happened.
Yeah, I was so painful what was happening. When he was like going through.
He just left.
Yeah, he was just like, bye. I was thinking, okay. That was good. I mean,
You got one that's not working out?
So I think.
Thank you.
Multiply these.
Or how would I?
Well, I don't know that you have to simplify it or not. You just need to be able to type it in.
How many?
So, I don't know, maybe make a fraction that's -5.
My one just doesn't
Shouldn't that be 5x squared? I mean, based on what you have down, I don't know about the rest, I didn't know what you have.
Well, it's so if the derivative was -5 over x squared, and then times negative log of x, and then plus 1 over x, that times 5 over x. So
Okay, hold on, I can't do that. So the derivative of 5 over -5 over x squared times the denominator left alone, or not, like, plus, then the derivative, the other one, which would be 1 over x times the other one left alone. Yeah, that sounds fine.
how would I type that then?
Well, I think you're typing it in just fine. And then if you multiply these, that would be 5 over x squared. And I think it has a way to like determine if your answer is equivalent to what they have. So, I think it plugs in, probably like plugs in some weird random number and then like compares decimals behind the scenes to see if it's the same.
Can I go out into the hallway real quick to see this will load better?
I just simplified it. And you told me wrong for it.
Guys, we are down to about 5 minutes till you're dismissed. So, if you did not finish off the number 24 circuit, you need to do that first. Spell that correctly. You need to finish the 2 Khan Academies. So at that point, you should be feeling pretty confident about power rule, product rule, and quotient rule, because you got a handful of practice out of each of those. And if you didn't turn in 22, you need to have that in Google Classroom before the start of class next time. That's when it is cut off, and then you'll get late credit. Also, that was a longer book assignment, so I made it worth more points, which should be a good thing for you. But if you end up forgetting and turning it in late, then you're losing more points that way too. So if you think you're going to have any homework, you might jot this down before you forget. Circuit needs to be finished, 24. Both Khan Academies need to be 100%ed, 25. As always, you're welcome to retry those as many times as it takes till you get it. And I need your homework from last week, 22 in Google Classroom. I need all of that by Wednesday. Also, this is a B week, so I only see you guys one more time this week, and we will look at the chain rule, which is the last of the derivative types you've got to be able to do by hand. But even chain rule questions, that comes after you do the power rule, or after you do product rule, or after you do quotient rule. So you really need to feel good with power rule, quotient rule, and product rule so that it doesn't just get harder. Then you can find a stopping place. Please bring my calculators back. If you borrowed one.
Yeah. You have to.
Yeah.
I have to run.
No, it's hard.